Welcome to another peaceful evening with Sleepy Long Scientists, where we gently explore the wonders that await humanity among the stars. Tonight, we're embarking on the most extraordinary journey our species has ever imagined, a quiet voyage to Mars, the rusty red world that has been patiently waiting for us in the cosmic darkness for billions of years. As you settle into your cozy spot here on Earth, imagine looking up at the night sky and spotting that familiar reddish twinkle, knowing that someday soon, humans will call that distant world home. This isn't science fiction anymore, it's the beautiful reality of humanity's next great adventure, where brave explorers will take their first gentle steps on alien soil and begin building our second home among the stars. Before we drift together toward the red planet, if these cosmic journeys help you unwind and dream of infinite possibilities, a soft subscribe would mean the universe to us. Now, let's float peacefully toward Mars, where humanity's greatest adventure is about to unfold with the patient grace of pioneers who understand that the most important journeys happen one careful step at a time. Have you ever found yourself lying on your back on a clear night, gazing up at the vast tapestry of stars, when suddenly your eyes catch that one distinctive reddish point of light that seems to pulse with mysterious energy? That's Mars. And there's something almost magical about the moment you first really notice it, not just as another star, but as an actual world. A place where you could theoretically stand and look back at Earth as just another point of light in an alien sky. I remember the first time this realization truly hit me. I was maybe 8 years old, lying in my backyard after my parents had pointed out different planets, when I suddenly understood that Mars wasn't just a dot of light. It was a real place, with mountains and valleys, storms and seasons, maybe even ancient rivers that once flowed across landscapes no human had ever seen. That night, I found myself wondering what it would feel like to take the first human steps on that rusty surface, to breathe air that had been processed by machines, to watch Earth rise over a Martian horizon. It was both thrilling and oddly comforting, this idea that humans might not always be confined to just one world, that our curiosity and ingenuity could carry us to places that had existed only in dreams and science fiction stories. Tonight, we're going to explore how that childhood wonder is becoming humanity's most ambitious reality, as we prepare to make Mars not just a destination we visit, but a world where humans will live, work, love, and build the first chapters of our multiplanetary future. Of all the worlds in our solar system, Mars has always felt like the one that was quietly calling to us, extending an invitation written in rust-colored dust in ancient riverbeds. There's something almost intentionally welcoming about our neighboring planet, as if the universe designed it specifically to be humanity's next home. When we look at the other planets in our cosmic neighborhood, they seem almost impossibly hostile. Venus, with its crushing atmosphere and surface hot enough to melt lead, Jupiter as a swirling giant of gas and storms, Mercury alternately freezing and broiling as it races around the sun. But Mars feels different. It feels patient, accessible, like a world that's been waiting for us to develop the wisdom and technology to make the journey. The most remarkable thing about Mars is how familiar it feels, even though it's an entirely alien world. A Martian day lasts 24 hours and 37 minutes, so close to an Earth day that our circadian rhythms would barely need to adjust. Mars has seasons just like Earth does, caused by the gentle tilt of its axis as it orbits the Sun. These seasons last about twice as long as Earth's because Mars takes nearly 2 Earth years to complete its orbital journey. But the rhythm would feel natural to any human who has experienced the cycle of spring, summer, autumn, and winter. There's something deeply comforting about knowing that on Mars, we could still experience the gentle passage of seasonal time, watching the planet's polar ice caps grow and shrink, just as we watch snow come and go in Earth's winter regions. Planet's size makes it feel almost perfectly scaled for human habitation. Mars is about half the size of Earth, which means its gravity is roughly 38% of what we experience here at home. This reduced gravity wouldn't be so light as to make movement impossibly difficult, but it would give humans a gentle boost, making it easier to carry heavy equipment, allowing us to jump a little higher, and reducing the stress on our joints and bones. Children born on Mars would grow up with this lighter touch of gravity as their normal experience, possibly growing taller and more graceful than their Earthbound cousins, Ancient civilizations seemed to sense something special about Mars long before they understood what planets actually were. The Romans named it after their god of war, not because it seemed threatening, but because its steady red glow reminded them of the color of blood and iron, the materials of strength and determination. The Egyptians called it Herdesha, meaning the red one, and tracked its movement across the sky with the same careful attention they paid to the flooding of the Nile. These early astronomers intuited that Mars was different from the other wandering stars, that it held secrets worth watching and wondering about. The gentle orbital dance between Earth and Mars creates windows of opportunity that feel almost like cosmic invitations. Every 26 months, Mars comes closer to Earth in what astronomers call an opposition, when the red planet shines brighter in our night sky and seems to pulse with extra energy. These moments have inspired generations of telescope observations, science fiction stories, and dreams of interplanetary travel. It's as if Mars is periodically waving at us, reminding us that it's there, patient and waiting, ready to welcome us when we develop the courage and capability to make the journey. The landscape of Mars, revealed through decades of robotic exploration, tells a story that feels surprisingly Earth-like in many ways. The planet has polar ice caps that advance and retreat with the seasons, massive canyons that dwarf the Grand Canyon, and ancient riverbeds that speak of a time when liquid water flowed freely across the Martian surface. There are dust storms that can engulf the entire planet, creating weather patterns that, while more extreme than Earth's, follow principles that human meteorologists can understand and eventually predict. Perhaps most importantly, Mars has water, not flowing on the surface today, but locked in ice at the poles and possibly in underground reservoirs that could sustain human life. This water represents the difference between Mars being a place humans might visit and Mars being a place where humans could actually live and build a civilization. The presence of water makes agriculture possible, provides the raw material for creating breathable air, and offers the psychological comfort of knowing that this most essential element of life is available on our new world. Mars calls to us not just as a destination for exploration, but as a world where humanity could write its next chapter. The red planet offers us the rare combination of challenge and possibility that has always brought out the best in human nature. Difficult enough to require our greatest ingenuity and cooperation, but welcoming enough to make success genuinely achievable with patience, wisdom, and the gentle persistence that has carried our species through every previous great adventure. The journey from dreaming about Mars to actually planning human missions there represents one of the most beautiful examples of how human imagination and scientific rigor can work together to transform the impossible into the inevitable. For over a century, writers, dreamers, and visionaries have been planting seeds of possibility in the collective human consciousness, creating detailed stories about what life on Mars might look like, how we might get there, and what we might find when we arrive. These weren't just fantasies, they were careful thought experiments that helped generations of scientists and engineers understand what problems they would need to solve to make interplanetary travel a reality. The early science fiction writers like H.G. Wells and Edgar Rice Burroughs didn't just entertain readers with tales of Martian adventures, they introduced entire generations to the concept that other worlds could be habitable, that humans could adapt to alien environments, and that space travel might someday become as routine as crossing an ocean. These stories created a cultural foundation of expectation and excitement that would eventually inspire the scientists and engineers who would turn fiction into fact. When young people read about John Carter's adventures on Mars, or listened to Orson Welles' famous radio broadcast about Martian invasion, they weren't just being entertained, they were having their imaginations expanded to include possibilities that previous generations had never seriously considered. The transition from pure imagination to serious scientific planning happened gradually, almost imperceptibly, as rocket technology developed through the mid-20th century. Visionaries like Konstantin Tsiolkovsky and Hermann Oberth began working out the actual mathematics of space travel, calculating the energy requirements for escaping Earth's gravity and the orbital mechanics needed to reach other planets. Their work laid the theoretical foundation that would eventually support the Apollo missions, proving that humans could indeed leave Earth and safely return. Each successful space mission, from Sputnik to Gagarin's flight to the moon landings, moved the dream of Mars exploration from the realm of fantasy closer to the realm of practical planning. The robotic exploration of Mars over the past several decades has been like sending advanced scouts to map the territory before human settlers arrive. Each Mars mission has answered crucial questions about the planet's atmosphere, geology, weather patterns, and potential for supporting life. The Viking landers of the 1970s proved that we could successfully land complex machinery on the Martian surface. The Mars Pathfinder mission demonstrated that rovers could operate autonomously on another planet. The ongoing work of Curiosity, Perseverance, and other rovers has provided detailed information about Martian soil chemistry, water availability, and the planet's geological history that mission planners need to design human habitats and life support systems. What makes the current phase of Mars mission planning particularly exciting is how it represents the convergence of multiple technological advances that are finally making human missions feasible. Private space companies like SpaceX have dramatically reduced the cost of launching payloads into orbit, making it economically realistic to send the large amounts of equipment that Mars colonists will need. Advances in 3D printing technology mean that future Mars settlers will be able to manufacture tools, spare parts, and even building materials using local Martian resources rather than shipping everything from Earth. Improvements in life support systems, developed for the International Space Station, have proven that humans can live in closed-loop environments for extended periods while recycling air, water, and even waste products. The psychological and social challenges of Mars colonization have also been the subject of careful scientific study, moving the discussion beyond the purely technical questions of rockets and life support systems. Researchers have studied how humans adapt to isolation, confinement, and the psychological stress of being far from Earth by conducting analog missions in remote locations like Antarctica and the Hawaiian volcanic deserts. These studies have helped mission planners understand how to select crew members who will work well together during the long journey to Mars and how to design habitats and work schedules that will maintain mental health and social cohesion in an alien environment. Perhaps most importantly, the dream of Mars colonization has evolved from a vague fantasy about escape from Earth to a carefully considered plan for expanding human civilization and ensuring our species' long-term survival. Modern Mars mission planners aren't just thinking about how to get humans to Mars, they're developing comprehensive strategies for creating self-sustaining settlements that could eventually become independent of Earth. This represents a fundamental shift in thinking, from Mars as a destination for heroic exploration to Mars as humanity's insurance policy and the first step toward becoming a multiplanetary species. The beautiful thing about this evolution from dreams to science is how it demonstrates that the most important human achievements often begin with someone imagining what might be possible, then dedicating themselves to the patient work of figuring out how to make it real. The journey to Mars represents the culmination of centuries of human curiosity, ingenuity, and the quiet determination to turn our greatest dreams into our most amazing realities. The voyage from Earth to Mars represents one of the most profound journeys humanity will ever undertake, not just because of the vast distance involved, but because of the gentle transformation that happens to human consciousness during the 9 months of drifting through the cosmic ocean between worlds. Unlike the dramatic rocket launches and splashdowns we associate with space travel, the actual journey to Mars will be characterized by patience, contemplation, and the slow development of a completely new relationship with time, space, and what it means to call a place home. The spacecraft carrying humanity's first Mars colonists will need to become a perfect miniature world, a closed-loop ecosystem capable of sustaining human life for the duration of the journey. This isn't just an engineering challenge, it's an exercise in creating a new form of human community, where every resource is precious, every system is interdependent, and every person's well-being affects the entire group. The crew will develop daily routines that blend the practical necessities of spacecraft maintenance with the psychological needs of humans who are gradually moving farther from Earth than any human has ever been. Morning might begin with checking atmospheric processors and water recycling systems, continue with scientific observations and physical exercise, and conclude with evening conversations where the crew shares meals while watching Earth slowly shrink from a blue marble to a pale blue dot to just another star among thousands. The psychological journey of traveling to Mars may be even more profound than the physical one. During the first weeks of the voyage, Earth will still be visible as a beautiful blue sphere that crew members can identify as home. But as the months pass and Earth becomes smaller and smaller, eventually disappearing entirely into the starfield, the crew will experience a gradual shift in their relationship with the concept of home. Mars, initially just a reddish point of light ahead of them, will slowly grow larger and more detailed, eventually becoming a real world with visible surface features, weather patterns, and the unmistakable sense of being a destination rather than just a distant goal. The rhythm of life during the Mars journey will be unlike anything humans have previously experienced, without the familiar cycle of day and night provided by Earth's rotation. The crew will need to create their own temporal structure using artificial lighting and carefully planned schedules. They'll develop new forms of entertainment and social interaction adapted to the constraints of their spacecraft environment. Exercise will become both a physiological necessity to maintain muscle mass and bone density in zero gravity, and a meditative practice that helps crew members process the enormity of their undertaking. Scientific observations of space, regular communications with Earth, and maintenance of spacecraft systems will provide structure and purpose to days that might otherwise blend together in the timeless environment of deep space. Communication with Earth will gradually shift from real conversations to an exchange of letters as the distance increases the delay between sending a message and receiving a response. This enforced patience will teach the Mars crew new forms of communication, where thoughts must be more carefully considered and emotional support must be offered in ways that account for the growing temporal gap between worlds. Families on Earth will send video messages, photos, and news updates that become precious gifts arriving across millions of miles of empty space. The crew will develop new rituals around receiving and sharing these messages from home, creating moments of connection that bridge the vast physical distance with love and shared experience. The approach to Mars will mark the beginning of a new phase of the journey as the red planet gradually transforms from an abstract destination to a real world with visible geography, weather systems, and the promise of solid ground beneath their feet. The crew will spend increasing amounts of time studying their new home through telescopes and cameras, learning to read Martian weather patterns, identifying landing sites and geographic features, and beginning the psychological transition from being travelers to being immigrants. This approach phase will blend excitement about reaching their destination with the natural human anxiety about starting a completely new life in an environment unlike anything their species has ever encountered. The final weeks of the journey will be filled with practical preparations for landing and the establishment of their initial settlement, but also with moments of quiet reflection about what they're leaving behind and what they're hoping to build. The crew will have spent 9 months learning to function as a perfectly coordinated team, developing skills and relationships that will serve as the foundation for the first human community on another planet. They'll have experienced the profound isolation of deep space travel and the gradual shift in perspective that comes from seeing Earth recede into the distance while another world grows larger and more welcoming ahead of them. By the time Mars fills their viewports and landing day approaches, the crew will have completed not just a physical journey between planets, but a psychological and spiritual transformation from Earth humans to interplanetary pioneers, carrying with them everything they've learned about patience, cooperation, and the gentle courage required to build human civilization in places where it has never existed before. The moment when human feet first touch Martian soil will be one of the most profound and quietly transformative events in the history of our species, marking the gentle transition from humanity as a single-planet civilization to our emergence as true cosmic citizens. This landing won't be the dramatic high-speed affair of science fiction movies, but rather a carefully orchestrated process that unfolds with the patience and precision of a ballet, performed in the rusty dust of an alien world. The spacecraft carrying humanity's first Martian settlers will descend through the thin atmosphere using a combination of heat shields, parachutes, and retro-rockets, each system engaging at precisely the right moment to ensure a landing so gentle it will barely disturb the ancient soil that has been waiting billions of years for this moment. The first human to step onto Mars will pause at the threshold of the landing craft, looking out at a landscape that is both utterly alien and strangely familiar. The horizon will stretch away in gentle curves colored in shades of rust and amber, punctuated by rocks and small craters that tell the story of eons of cosmic bombardment and wind erosion. The sky will be a pale butterscotch color during the day, quite different from Earth's blue, but somehow beautiful in its own way. That first step will be taken slowly, deliberately, with the understanding that this moment represents not just a personal achievement, but the beginning of humanity's expansion into the cosmos. The immediate priorities after landing will be both practical and profoundly symbolic. The crew will need to quickly establish their basic life support systems, setting up the equipment that will transform their landing site from a spot of alien ground into humanity's first foothold on another world. Solar panels will be deployed to capture the weaker Martian sunlight. Atmospheric processors will begin the work of extracting oxygen from the carbon dioxide-rich air, and communication arrays will be established to maintain the vital link with Earth. But between these urgent tasks, there will be moments of quiet wonder as the crew members take their first walks on Martian soil, feeling the strange lightness that comes from gravity, only 38% as strong as Earth's. The psychological impact of standing on Mars will be unlike anything humans have previously experienced. Looking up at the Martian sky, the astronauts will see two small moons, Phobos and Deimos, racing across the heavens much faster than Earth's familiar moon. During certain times of the Martian day, Earth will be visible as a bright blue star, a reminder of home that is both comforting and sobering in its distance. The silence of Mars will be profound, broken only by the gentle wind that constantly sculpts the landscape and the sounds of human activity as the crew works to establish their new home. The process of transforming a landing site into a settlement will begin immediately, but it will unfold with the patient, methodical approach that space exploration demands. The crew will start by creating a small pressurized habitat using prefabricated modules that were sent ahead of their arrival. This initial shelter will be modest, perhaps no larger than a small house, but it will represent something extraordinary. The first human dwelling built on another planet. Inside this habitat, the crew will recreate the essential elements of human comfort: breathable air, clean water, a place to prepare and share meals, private spaces for rest and reflection, and common areas where they can gather to plan their work and maintain the social bonds that will be crucial for their psychological well-being. The early days on Mars will establish routines and traditions that will likely be followed by generations of future colonists. Morning activities might include checking all life support systems, reviewing weather conditions, and planning the day's exploration and construction activities. The crew will venture out in pressurized suits to begin the work of expanding their settlement, perhaps starting with the construction of a greenhouse where they can begin growing fresh food in Martian soil. Evening routines will likely include scientific observations, communication sessions with Earth, and shared meals where the crew processes the experiences of living on an alien world. The first weeks and months on Mars will be a delicate balance between the urgent work of survival and the profound human need to explore and understand their new environment. Short expeditions from the base camp will gradually map the local area, collecting samples, identifying resources, and beginning to understand the rhythms of Martian weather and geology. Each discovery will add to humanity's understanding of their new world while also providing practical information needed for the long-term success of the settlement. Perhaps most importantly, these first Martian settlers will begin the process of learning how to be human on another world, developing new traditions, customs, and ways of living that blend the essential elements of human culture with the unique requirements of life on Mars. They will become the bridge between humanity's earthbound past and our multiplanetary future, carrying forward the best of human civilization while adapting to create something entirely new among the rust-colored hills of our second home. Creating a true home on Mars will require humanity to master the gentle art of making an alien world feel familiar and welcoming, transforming the rust-colored desert into spaces where humans can not just survive, but truly thrive and find comfort. This process will begin with the most basic shelter and gradually evolve into something far more profound: the creation of environments that nurture the human spirit while protecting the human body from the harsh realities of life on another planet. The early Martian settlers will become master architects of adaptation, learning to blend cutting-edge technology with the timeless human need for beauty, comfort, and the sense of belonging that transforms any structure into a genuine home. The initial habitation modules will arrive on Mars before the first human settlers, deployed by robotic systems and powered by nuclear reactors that can operate reliably in the planet's challenging environment. These prefabricated structures will be marvels of engineering efficiency, designed to provide maximum living space while using minimum resources. But the real magic will happen when humans arrive and begin the process of personalization that turns sterile functional spaces into warm, inviting homes. The settlers will bring with them carefully selected personal items, photographs, books, musical instruments, art supplies that will gradually transform bare walls into spaces that reflect human personality and creativity. The revolutionary technology that will make Martian construction possible is 3D printing using local materials. Robotic printers will work around the clock, using Martian soil mixed with binding agents to create building blocks, structural elements, and even decorative features for the growing settlement. This technology will allow the colonists to build structures that are perfectly adapted to Martian conditions, with thick walls to provide insulation and radiation shielding, airlocks to maintain atmospheric pressure, and curved surfaces that can better withstand the planet's occasional dust storms. The gentle hum of 3D printers working through the Martian night will become the sound of human civilization taking root on an alien world. The interior spaces of Martian homes will need to serve multiple functions while maintaining the psychological comfort that humans require for mental health and well-being. Living areas will be designed with soft lighting that mimics Earth's natural day-night cycle, helping residents maintain their circadian rhythms despite the slightly longer Martian day. Walls will be lined with growing systems where plants can provide fresh air, food, and the green beauty that connects humans to the natural world. These indoor gardens will become the heart of Martian homes, creating oases of Earth-like life that provide both practical benefits and emotional comfort. The common areas of the settlement will be designed to foster the sense of community that will be essential for the psychological health of the colonists. A central gathering space will serve as dining hall, meeting room, and social center where residents can share meals, celebrate special occasions, and simply enjoy each other's company during the long Martian evenings. Workshop areas will allow colonists to pursue hobbies, create art, and maintain the equipment that keeps their world running. Libraries and recreation spaces will provide quiet retreats where individuals can find solitude and mental stimulation when they need time away from the intense cooperation that Martian life will require. The expansion of the settlement will happen gradually, organically, as the colony grows from a small outpost to a genuine town. New residential modules will be connected to the original structures through pressurized corridors, creating a growing network of human habitation that spreads across the Martian landscape like a gentle flowering of civilization. Each new addition will incorporate lessons learned from earlier construction, gradually improving the design and comfort of Martian architecture. Specialized buildings will emerge, workshops, laboratories, greenhouses, and eventually schools, where the first generation of Martian children will learn about both Earth's history and their new world's possibilities. The aesthetic of Martian architecture will evolve to reflect both the practical requirements of life on an alien world and the human desire for beauty and meaning in their surroundings. Buildings will be designed to complement the natural Martian landscape rather than imposing foreign concepts upon it. Earth-toned exteriors will blend harmoniously with the rust-colored soil, while interior spaces will feature the colors and textures that humans find most comforting and inspiring. Art and decoration will play crucial roles in making these spaces feel like home, with colonists creating murals, sculptures, and gardens that celebrate both their Earth heritage and their Martian present. Perhaps most importantly, the process of building homes on Mars will teach humanity new lessons about what we truly need to feel comfortable and fulfilled. Stripped of many of the material possessions and conveniences that define Earth-based living, Martian settlers will rediscover the fundamental elements that make a space feel like home: safety, beauty, community, and the opportunity for both privacy and social connection. The homes they build in the Red Desert will become models for sustainable, efficient, and deeply human ways of living that may eventually influence architecture and community planning back on Earth, proving that the challenges of life on Mars can inspire innovations that benefit all of humanity. In the heart of every Martian settlement will stand humanity's most precious and life-giving structure, the greenhouse, a transparent cathedral of green life that will serve as both the practical foundation of survival and the spiritual center of hope for colonists. Living millions of miles from Earth, these climate-controlled gardens will represent far more than agricultural facilities. They will be oases of familiar life in an alien landscape, places where the colors, scents, and gentle sounds of growing plants will remind homesick colonists of the verdant world they left behind while providing the fresh food and clean air that will keep them healthy and alive on their new planet. The Martian greenhouse will be a marvel of engineering and biology, designed to create perfect growing conditions using the challenging resources available on the red planet. The structure itself will need to be both transparent enough to let in the weaker Martian sunlight and strong enough to maintain Earth-like atmospheric pressure against the near vacuum outside. Advanced materials will filter harmful radiation while allowing photosynthesis to proceed, and the entire facility will be designed to capture and recycle every drop of water, every breath of carbon dioxide, and every scrap of organic matter in the closed-loop systems that will be essential for long-term survival. Inside these pressurized gardens, Earth plants will learn to thrive under alien skies, their roots extending into carefully prepared growing media that blends processed Martian soil with composted organic matter from the settlement. The reduced gravity of Mars will create unique growing conditions where plants may grow taller and more delicate than their Earth counterparts, supported by the gentler pull that makes everything on Mars feel slightly lighter and more graceful. Tomatoes will climb toward the butterscotch-colored sky visible through the transparent ceiling, while lettuce and herbs will spread their leaves in the soft, filtered light that has traveled millions of miles from the sun to nourish life on humanity's second home. The daily routine of tending the Martian greenhouse will become one of the most meditative and restorative activities available to the colonists. Working with soil and seeds, watering plants, and harvesting fresh vegetables will provide a direct connection to the agricultural traditions that have sustained human civilization for thousands of years. The greenhouse will offer a refuge from the high-tech, engineering-focused work that will dominate most aspects of life on Mars, giving colonists the opportunity to work with their hands, connect with living systems, and experience the quiet satisfaction that comes from nurturing growth and abundance. The psychological benefits of the greenhouse will be just as important as its practical contributions to colony survival. The green color of growing plants will provide visual relief from the endless rust and amber tones of the Martian landscape, while the humid air inside the greenhouse will feel refreshingly different from the dry, processed atmosphere of the main habitat modules. The sense of growing herbs and ripening vegetables will trigger powerful memories of earth gardens, farmers markets, and home-cooked meals, providing emotional comfort during moments when the isolation and strangeness of Mars feel overwhelming. The greenhouse will also serve as the colony's center for botanical research and agricultural innovation. Colonists will experiment with new growing techniques specifically adapted to Martian conditions, developing hydroponic and aeroponic systems that use minimal water while maximizing yield. They will test different varieties of earth plants to determine which ones adapt best to the unique combination of reduced gravity, altered atmospheric pressure, and modified light spectrum that characterizes the Martian environment. Some plants may thrive beyond all expectations, while others may struggle, leading to the gradual development of a uniquely Martian agriculture that blends Earth wisdom with alien innovation. The expansion of food production will gradually move beyond basic survival crops to include the herbs, spices, and specialty plants that make meals enjoyable rather than merely nutritious. Imagine the joy of the first Martian colonist to successfully grow coffee beans or cocoa plants, bringing the comforting rituals of morning coffee or evening chocolate to their alien home. Fresh herbs will transform simple meals into celebrations, while the successful cultivation of fruit trees will provide both nutrition and the psychological comfort of foods that connect directly to memories of earth orchards and family traditions. The greenhouse will become a gathering place where colonists can work together on the shared task of growing food, while enjoying informal conversations and the companionship that makes any challenging situation more bearable. Children born on Mars will learn their first lessons about biology and agriculture in these green spaces, developing an understanding of how life systems work that will serve them well as they grow up to become the next generation of Martian farmers and gardeners. Perhaps most remarkably, the success of Martian greenhouses will prove that life is incredibly adaptable and resilient, capable of thriving in conditions far removed from its original environment when given the right support and care. These gardens will demonstrate that humans can indeed create livable, beautiful, and nourishing environments anywhere in the universe where we have the knowledge, technology, and determination to recreate the essential conditions that support the green miracle of photosynthesis. and growth. Water is the gentle miracle that will transform Mars from a destination for heroic exploration into a genuine home for human civilization. And discovering the surprising abundance of this precious resource hidden beneath the planet's dusty surface has been one of the most encouraging revelations of our robotic reconnaissance missions. The red planet, which appears so dry and desolate from space, actually holds vast quantities of water locked away in polar ice caps, underground reservoirs, and even in the soil itself, waiting patiently to support the first human settlements. With the most essential ingredient for life as we know it, the polar ice caps of Mars represent the most obvious and accessible water reserves on the planet, containing enough frozen water to cover the entire Martian surface in a layer several feet deep if it were to melt all at once. These gleaming white caps, visible even through small telescopes from Earth, grow and shrink with the Martian seasons just like polar ice on our home planet, demonstrating that Mars still maintains active water cycles despite its thin atmosphere and cold temperatures. The northern polar cap is particularly promising for human settlements, composed primarily of water ice with only thin layers of frozen carbon dioxide, making it relatively straightforward to harvest using solar-powered melting and purification systems. But perhaps even more exciting than the polar ice are the underground water reservoirs that scientists have discovered throughout the Martian subsurface. Radar observations from orbiting spacecraft have revealed extensive aquifers, underground layers of water-saturated soil and rock, that exist at depths ranging from just a few feet to several hundred feet below the surface. Some of these underground water sources may actually be liquid even today, kept from freezing by the insulating effect of soil layers above, and possibly by dissolved salts that lower the freezing point, creating hidden oases that could be tapped by future colonists willing to dig wells and install pumping systems. The process of extracting and purifying Martian water will become one of the most crucial technologies that human settlers must master, transforming the ancient H2O molecules that have been locked in Martian ice and soil for millions of years into the clean, pure water that human bodies require. Solar concentrators and electric heating elements will gently melt ice and evaporate soil moisture, while filtration and purification systems will remove the salts and minerals that make much Martian water unsuitable for direct consumption. The first glass of pure Martian water, consumed by human settlers, will represent a profound moment of connection between our species and our new world, as we literally incorporate the substance of Mars into our bodies. Water recycling will become an art form on Mars, where every drop will be precious and nothing can be wasted. Advanced closed-loop systems will capture water from human respiration, perspiration, and waste products, purifying and recycling it through biological and mechanical filters until it emerges as clean, fresh water ready for drinking, cooking, and agricultural use. The water that a colonist drinks for breakfast might have been used to water plants the day before, demonstrating the circular economy that will be essential for long-term survival on a world where resupply from Earth is impossible except at enormous cost and effort. The psychological impact of having abundant water on Mars cannot be overstated for settlers who will be living in an environment where so many familiar comforts are unavailable. The sound of running water from taps and showers will provide acoustic comfort that connects to deep human memories of streams, rivers, and rainfall. Hot baths and showers will offer not just hygiene and physical comfort, but also psychological relief from the stresses of life in an alien environment. Swimming pools, while perhaps a luxury for later stages of colony development, could provide both recreation and exercise opportunities that help maintain physical fitness and mental health. The discovery of water on Mars also opens up possibilities for large-scale terraforming projects that could gradually make parts of the planet more Earth-like over centuries or millennia. Released water vapor could thicken the Martian atmosphere, creating a stronger greenhouse effect that would warm the planet and possibly allow liquid water to exist on the surface in some regions. While such planetary-scale engineering projects are far beyond current human capabilities, the abundance of water on Mars makes these long-term visions at least theoretically possible. Water will also serve as the raw material for creating breathable air and rocket fuel on Mars. As systems split H2O molecules into hydrogen and oxygen, this means that the same water reserves that keep colonists alive and healthy will also provide the oxygen they breathe and the fuel needed for return trips to Earth or exploration missions to other parts of the solar system. Perhaps Most remarkably, every drop of water that future Mars colonists will drink carries within it the history of the red planet itself, water molecules that may have flowed in ancient Martian rivers, fallen as snow on alien mountains, or been locked in polar ice. 4 geological ages. In drinking Martian water, human settlers will be connecting themselves to the deep history of their new world, participating in water cycles that began long before Earth even had complex life. The gentle act of breathing on Mars will require one of humanity's most ingenious achievements, the transformation of an alien atmosphere, composed mostly of carbon dioxide, into the life-giving oxygen that fills our lungs with every breath. Mars greets arriving humans with an atmosphere that is almost entirely unbreathable, containing less than 1% oxygen, and maintaining a pressure so low that human blood would literally boil without protective equipment. Yet hidden within this hostile environment lies everything needed to create breathable air, waiting to be unlocked by the patient work of atmospheric processors that will quietly transform the red planet's thin breath into the precious oxygen that sustains human life. The technology that makes breathing Martian air possible centers around a remarkable device called MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, which has already proven its effectiveness during the Perseverance rover mission. This ingenious machine works by taking in Martian atmospheric carbon dioxide and using high temperatures to split the CO2 molecules, separating out pure oxygen while releasing carbon monoxide back into the atmosphere. The process is elegantly simple in concept, but requires precise engineering to operate reliably in the challenging conditions of Mars, where dust storms, temperature extremes, and the corrosive effects of the Martian environment test every mechanical system to its limits. For the first human settlements, these atmospheric processors will run continuously, creating gradually expanding bubbles of breathable atmosphere around the initial landing sites. The early colonists will live within pressurized habitats where Earth-normal atmospheric pressure and oxygen concentrations can be maintained. But they will also begin the work of expanding these oxygenated zones through the steady operation of increasingly sophisticated air-making equipment. Each day, more carbon dioxide will be converted to oxygen, slowly building up reserves that provide both breathing air for the colonists and the psychological comfort that comes from knowing their life support systems have built-in redundancy and safety margins. The experience of breathing artificially created air will initially feel strange to Mars colonists, as their lungs fill with oxygen that was literally manufactured from the alien atmosphere around them. But gradually, this processed air will become as natural and familiar as breathing anywhere else, and colonists will develop an intimate appreciation for the quiet miracle of atmospheric engineering that keeps them alive. The gentle hum of oxygen generators will become the sound of life itself on Mars, as reassuring as a heartbeat and as essential as the circulation of blood through human veins. The expansion of breathable atmosphere beyond the initial habitats will happen gradually, creating larger and larger areas where humans can work and live without bulky pressure suits. These expanded atmospheric zones will be created using transparent enclosures, enormous greenhouse-like structures that can maintain Earth normal pressure while allowing natural light to penetrate. Walking through these pressurized corridors and work areas will feel like moving through transparent tunnels of life, where the boundary between human habitation and the alien environment outside is clearly visible but safely contained. Plants will play a crucial role in maintaining air quality within Martian settlements, serving as both backup oxygen generators and natural air purifiers that remove carbon dioxide and other contaminants from the breathing atmosphere. The settlement's greenhouse facilities will become the lungs of the colony, where photosynthesis provides a biological complement to the mechanical oxygen generators. The sight of green leaves, releasing tiny bubbles of oxygen into the settlement's atmosphere, will create a visual reminder of the partnership between human technology and natural biological processes that makes life on Mars possible. The psychological impact of creating breathable air on Mars extends far beyond the simple provision of oxygen for human lungs. The ability to remove a helmet and breathe freely, even if only within the pressurized confines of a habitat, will provide profound psychological relief from the constant awareness of life. Support systems that characterize space exploration. Deep breathing exercises will become not just relaxation techniques, but celebrations of the successful transformation of an alien world into a place where human lungs can function naturally. Emergency air supplies and backup oxygen generation systems will be designed with multiple redundancies, ensuring that colonists never face the terrifying prospect of being unable to breathe on their new world. Portable oxygen concentrators will allow extended expeditions outside the main settlement areas, while emergency air supplies will provide safety margins that account for equipment failures, dust storms that might interfere with solar systems, and the gradual expansion of the colony beyond the capacity of existing atmospheric processors. The long-term vision for atmospheric modification on Mars includes the possibility of gradually thickening the planet's entire atmosphere through the release of greenhouse gases that could warm the planet and increase atmospheric pressure. While such planetary-scale atmospheric engineering remains far beyond current human capabilities, the successful operation of local atmospheric processors will provide the proof of concept and technological foundation for these more ambitious projects. Perhaps most remarkably, every breath taken by Mars colonists will represent a triumph of human ingenuity over environmental challenges, demonstrating our species' ability to create the conditions for life in places where life has never existed before, turning the hostile breath of an alien world into the gentle, life-sustaining air that fills human lungs with the promise of a multiplanetary future. Living by the rhythm of Mars will introduce human settlers to a gentle new way of experiencing time, as they adapt to days that last 24 hours and 37 minutes, just long enough to feel slightly different from Earth time, but close enough to feel comfortably familiar. This extra 37 minutes each day, called a soul by planetary scientists, will gradually shift the relationship between human activity cycles and the solar day, creating a slow drift that means Martian colonists will experience noon at different times relative to their Earth-based clocks as the weeks and months pass. This temporal adjustment will become one of the subtle but profound ways that living on Mars changes human consciousness, as settlers develop new internal rhythms that sync with their alien world rather than their distant home planet. The Martian sunrise will become a daily source of wonder and beauty for colonists, as the sun appears smaller and more distant than it does from Earth, casting a gentler, more diffuse light across the rust-colored landscape. The morning light on Mars has a unique quality, softer and more golden than Earth's bright white sunlight, that will gradually become as familiar and comforting to colonists as any earthly dawn. Morning routines will blend the practical necessities of checking life support systems and reviewing weather conditions with the deeply human ritual of greeting the day. Perhaps with a cup of coffee made from beans grown in the settlement's greenhouse while watching the sun rise over alien horizons that feel more like home with each passing soul. The working day on Mars will be structured around the unique challenges and opportunities of life on an alien world, with colonists dividing their time between maintenance of essential systems, expansion of the settlement, scientific research, and the agricultural work that keeps everyone fed and healthy. The reduced gravity of Mars will make many physical tasks easier than they would be on Earth, allowing colonists to carry heavier loads and work for longer periods without the same level of physical fatigue. However, the need for pressure suits during outside work will add complexity to even simple tasks, requiring careful planning and coordination that makes every expedition beyond the pressurized habitats feel like a small adventure. Midday on Mars will bring its own unique character as the sun reaches its highest point in a sky that appears butterscotch or pale orange rather than blue. The atmospheric conditions on Mars create spectacular optical effects, with dust particles in the thin air scattering light in ways that produce beautiful halos around the sun and subtle color gradations across the sky that change throughout the day. Lunch breaks will often be spent in the greenhouse areas, where colonists can enjoy fresh vegetables and the psychologically comforting presence of green plants, while discussing the morning's work and planning afternoon activities. The afternoon work period will often focus on outdoor activities that take advantage of the warmest part of the Martian day. When temperatures might rise above freezing in the settlement area, this is when colonists will venture furthest from their base, conducting geological surveys, installing new equipment, or simply exploring the fascinating landscape that surrounds their new home. The alien geology of Mars will provide endless opportunities for discovery, with rock formations, small craters, and mineral deposits that tell the story of a planet's 4-billion-year history, written in stone and soil. Martian evenings will develop their own special magic, as the thin atmosphere creates sunset colors unlike anything seen on Earth. The sun will appear as a small, distant disk setting behind alien horizons, while the sky transforms through subtle gradations of blue, green, and salmon pink that seem to glow from within. Evening activities will center around the social life of the settlement, with communal dinners where colonists share food grown in their own greenhouse and discuss the day's discoveries and challenges. These evening gatherings will be crucial for maintaining the psychological health and social cohesion that make isolated communities successful. The Martian night will bring its own wonders, as two small moons, Phobos and Deimos, race across the star-filled sky much faster than Earth's familiar moon. Phobos, the larger and closer moon, will cross the entire sky in just over 4 hours, creating a dynamic celestial show that colonists will never tire of watching. Earth will be visible as a bright blue star in the Martian night sky, a reminder of home that provides both comfort and perspective on how far humanity has traveled to establish this new settlement. The gradual adjustment to Martian time will teach colonists new forms of patience and adaptation, as they learn to work with, rather than against, the natural rhythms of their new world. Sleep cycles will eventually synchronize with the slightly longer Martian day, and colonists will develop new traditions and customs that celebrate the unique temporal experience of life on Mars. Weekend concepts will evolve to fit Martian weeks, and holiday celebrations will incorporate both Earth traditions and new customs that reflect the unique experience of being human on another planet, creating the cultural foundation for a truly Martian civilization that honors its Earth heritage while embracing its alien future. The moment when the first child is born on Mars will mark one of the most profound transitions in human history, as our species evolves from earthbound creatures to truly multiplanetary beings who can call multiple worlds home. These pioneering Martian families will face the beautiful challenge of raising children who will grow up with a fundamentally different relationship to gravity, geography, and the very concept of what constitutes the natural world. The first generation of Martian children will develop in an environment where the red planets, rust-colored skies, and twin moons represent normal, everyday reality, while Earth becomes a distant blue star that their parents tell stories about during bedtime, a reversal that will reshape human consciousness in ways we can barely imagine. The physical development of children born on Mars will be subtly but significantly different from their Earth-born parents, as the reduced gravity creates conditions that have never existed in human evolutionary history. These Martian children may grow taller and more slender than Earth humans, with bones and muscles adapted to the lighter gravitational pull that makes jumping higher and moving with greater ease a natural part of their daily experience. Their cardiovascular systems will develop in response to the different atmospheric pressure and oxygen concentrations of their pressurized habitats, potentially creating physiological adaptations that make them perfectly suited for life on Mars, while perhaps making visits to Earth's heavier gravity more challenging as they grow older. Pregnancy and childbirth on Mars will require new medical protocols and technologies, as doctors learn to manage human reproduction in an environment where everything from fetal development to labor and delivery happens under conditions that no human has previously experienced. The reduced gravity may affect how babies develop in the womb, potentially leading to longer, more slender body proportions and different muscle development patterns. Martian hospitals will need specialized equipment designed for the unique conditions of the red planet, with medical staff who understand how to provide care in an environment where traditional Earth-based medical assumptions may not apply. The education of Martian children will blend the accumulated knowledge of human civilization with the practical skills needed for life on an alien world, creating a curriculum that spans literature and history from Earth alongside engineering, atmospheric science, and the agricultural techniques needed to sustain life on Mars. These children will learn to read both Shakespeare and atmospheric pressure gauges, to appreciate both Earth's blue skies and the subtle beauty of Martian sunsets, to understand both the history of their species and the geology of their new world. Their classrooms will feature windows looking out onto alien landscapes, while their textbooks will include chapters on maintaining life support systems alongside traditional subjects like mathematics and language arts. Martian children will develop games and play activities that take advantage of their unique environment, creating new forms of recreation that blend the universal human love of play with the specific opportunities offered by reduced gravity and an alien setting. They might invent jumping games that would be impossible on Earth, develop sports that take advantage of Mars's lighter gravitational pull, or create imaginative play scenarios that incorporate the real challenges and wonders of life on another planet. Their toys will likely include miniature rovers, spacesuits designed for play, and models of both Earth and Mars that help them understand their place in the cosmic neighborhood. The psychological development of children who grow up on Mars will be shaped by the unique combination of advanced technology and frontier living that characterizes early Martian settlements. These children will grow up understanding that their survival depends on the proper functioning of complex life support systems, making them naturally more aware of environmental systems and technological interdependence than most Earth children. At the same time, they will experience the pioneer spirit of living in a small, close-knit community where everyone's contribution matters, and where the landscape outside their windows represents the frontier of human exploration and settlement. Family traditions on Mars will evolve to incorporate both Earth customs and new celebrations that reflect the unique experience of life on the Red Planet. Holidays might include Earth celebrations like Christmas and New Year's, alongside new Martian observances that mark the anniversary of the colony's founding, the successful harvest of the first Martian-grown food, or the birthdays of the first children born on the planet. These families will create new coming-of-age traditions that might include a child's first solo expedition in a precious suit, their first successful cultivation of food plants, or their achievement of skills needed for the colony's survival and growth. Perhaps most remarkably, Martian children will grow up with a perspective on humanity's place in the universe that is fundamentally different from any previous generation. They will see Earth not as the only possible home for human life, but as humanity's birthplace, important and precious, but not limiting. These children will think naturally in terms of multiple worlds, interplanetary travel, and the expansion of human civilization throughout the solar system. They will become the bridge generation between humanity's single-planet past and our multiplanetary future, carrying forward the best of human culture, while pioneering new ways of being human that incorporate the lessons learned from growing up among the stars. Healthcare on Mars will represent a quiet revolution in human medicine, as doctors and medical researchers learn to practice healing arts in an environment where every assumption about human physiology, disease prevention, and treatment protocols must be carefully reconsidered and adapted to the unique conditions of life on another world. The reduced gravity, altered atmospheric pressure, increased radiation exposure, and psychological stresses of colonial life will create new challenges for maintaining human health, while also offering unexpected opportunities to understand how the human body adapts and heals in ways that were impossible to study on Earth. The practice of medicine on Mars will require a fundamental shift from treatment-focused healthcare to prevention-focused wellness, simply because the logistics of medical emergencies on a planet millions of miles from Earth make prevention infinitely more practical than cure. Martian medical protocols will emphasize regular health monitoring using advanced diagnostic equipment that can detect problems before they become serious, nutritional programs that maintain optimal health in an artificial environment, and exercise, REGIMENS, specifically designed to counteract the effects of reduced gravity on bone density, muscle mass, and cardiovascular fitness. Every colonist will become intimately familiar with their own health metrics, tracking everything from bone density to psychological well-being, with the same attention that they pay to atmospheric pressure and water recycling efficiency. The reduced gravity of Mars will create both opportunities and challenges for human health that medical science has never encountered before. On the positive side, the lighter gravitational pull will reduce stress on joints, potentially alleviating arthritis and back problems that plague many people on Earth. Recovery from injuries may be faster in some cases, as the reduced weight stress allows damaged tissues to heal without the constant mechanical stress of Earth's gravity. However, the long-term effects of reduced gravity on bone density, muscle atrophy, and cardiovascular conditioning will require ongoing medical research and the development of exercise protocols that maintain Earth-normal physical fitness. Despite the gentler gravitational environment, mental health care will become one of the most crucial aspects of Martian medicine, as the psychological challenges of life in an isolated, artificial environment far from Earth require new approaches to maintaining emotional and psychological well-being. Martian medical facilities will include dedicated spaces for counseling, meditation, and therapeutic activities that help colonists process the unique stresses of pioneer life. The medical staff will be trained not just in traditional psychological intervention techniques, but in the specific challenges of small group dynamics, homesickness, claustrophobia, and the existential questions that arise when humans find themselves living on another planet for the first time in history. The pharmaceutical approach to medicine on Mars will rely heavily on 3D printing and local manufacturing of medications, as the cost and logistics of shipping drugs from Earth make local production essential for any sustainable medical program. Martian medical facilities will include sophisticated laboratories capable of synthesizing essential medications from basic chemical components, many of which can be derived from Martian resources or manufactured using the settlement's industrial capabilities. This local pharmaceutical production will also enable medical researchers to experiment with new formulations and dosages, specifically adapted to the physiological changes that occur in Martian gravity and atmospheric conditions. Emergency medicine on Mars will require unprecedented levels of preparation and redundancy. As the nearest emergency backup is literally millions of miles away and reachable only during specific orbital windows every 2 years, surgical suites will be designed with multiple backup systems for everything from power supply to life support, while medical staff will be cross-trained in multiple specialties to ensure that critical care can be provided even if individual team members become unavailable. Every major piece of medical equipment will have backup systems and spare parts manufactured locally, creating a level of medical self-sufficiency that exceeds anything achieved on Earth. The unique radiation environment of Mars will require new approaches to cancer prevention and treatment, as the planet's thin atmosphere and lack of a strong magnetic field expose colonists to cosmic radiation levels that are significantly higher than those experienced on Earth. Medical protocols will include regular screening for radiation-induced health problems, protective medications that help the body repair radiation damage, and habitat design features that minimize exposure during daily activities. Paradoxically, this challenging radiation environment may also lead to medical breakthroughs in cancer treatment, as researchers develop new therapies for radiation-induced cancers that could benefit patients throughout the solar system. Reproductive medicine and pediatric care will represent entirely new frontiers in Martian healthcare, as medical staff learn to manage pregnancy, childbirth, and child development in an environment where reduced gravity and artificial atmospheric conditions create unprecedented variables in human reproduction. Martian medical facilities will include specialized equipment for monitoring fetal development, managing births in reduced gravity, and tracking the growth and development of children who represent humanity's first generation born on another planet. Perhaps most importantly, medicine on Mars will demonstrate the remarkable adaptability and resilience of the human body, proving that our species can maintain health and vitality in environments far removed from the African savannas where we evolved. The medical innovations developed for Mars will eventually benefit healthcare throughout the solar system, creating a foundation of space medicine that will support human expansion to even more challenging environments among the stars. The gentle extraction of resources from Mars will transform the red planet from a barren wilderness into humanity's first off-world industrial base, where robotic miners and human engineers work together to unlock the mineral treasures that have been patiently waiting beneath the Martian surface for billions of years. This isn't the dramatic, environmentally destructive mining that has sometimes scarred Earth's landscapes, but rather a careful, sustainable approach to resource extraction that treats Mars with the respect due to humanity's second home, while providing the raw materials needed to build a thriving interplanetary civilization. The robotic workforce that will do most of the actual mining on Mars represents a new generation of artificial intelligence and autonomous machinery, designed to operate reliably in the harsh conditions of an alien world where repair and maintenance must often be performed by other robots rather than human technicians. These mechanical miners will work around the clock, guided by AI systems that can identify promising mineral deposits, plan extraction operations, and coordinate with processing facilities to transform raw Martian ore into useful materials. The gentle hum of these machines working through the Martian night will become the industrial heartbeat of human civilization on the red planet, as constant and reassuring as the sound of atmospheric processors creating breathable air. The geology of Mars offers a treasure trove of resources that will support everything from basic construction to advanced manufacturing, with mineral deposits that are often more accessible and concentrated than their Earth equivalents. Iron oxide, the compound that gives Mars its distinctive rust color, will provide abundant iron for steel production, while the planet's volcanic history has created deposits of rare metals and minerals that are essential for electronics and advanced technology. Perhaps most importantly, Mars contains significant deposits of water, ice, which serves as the raw material not just for drinking water and agriculture, but also for the hydrogen and oxygen that will fuel spacecraft and provide breathing air for the growing human population. The processing of Martian minerals will happen close to the extraction sites, using mobile refineries and 3D printing facilities that can transform raw ore into finished products without the need to transport heavy materials across long distances. These processing facilities will use solar power and small nuclear reactors to provide the energy needed for smelting, refining, and manufacturing, creating an industrial infrastructure that operates independently of Earth-based supply chains. The sight of freshly manufactured steel beams, electronic components, and construction materials emerging from Martian foundries will represent one of the most tangible symbols of humanity's successful adaptation to life on another world. The mining operations will be designed with environmental sustainability as a primary concern, using techniques that minimize impact on the Martian landscape while maximizing resource recovery. Strip mining and open-pit operations will be limited to areas where they won't interfere with scientific research or future settlement expansion. While underground mining will be preferred for most mineral extraction, the mining sites will be carefully planned to avoid contaminating potential water sources or disturbing areas that might contain evidence of past or present Martian life, demonstrating that industrial development and scientific exploration can coexist respectfully on the Red Planet. The workforce involved in Martian mining will blend human oversight and decision-making with robotic labor and AI-assisted operations, creating a new model of industrial cooperation between humans and machines. Human miners and engineers will focus on planning, problem-solving, and equipment maintenance, while robots handle the dangerous, repetitive work of actual excavation and material transport. This partnership will allow mining operations to continue, even during dust storms or other weather conditions that might make surface work dangerous for humans, while ensuring that complex decisions and quality control remain under human supervision. The economic impact of Martian mining will eventually extend far beyond the Red Planet itself, as the lower gravity and reduced atmospheric drag make Mars an ideal staging area for mining operations throughout the asteroid belt and outer solar system. Materials mined on Mars can be launched into space much more easily than the same materials lifted from Earth's surface, making the Red Planet a natural hub for interplanetary trade and industrial development. Rare metals and minerals extracted from Martian deposits may eventually be shipped back to Earth, creating the first true interplanetary economy based on resource exchange between worlds. The mining industry on Mars will also drive innovation in recycling and resource efficiency, as the high cost of importing anything from Earth makes waste reduction and material reuse essential for economic viability. Mining operations will incorporate advanced recycling systems that can reclaim and reprocess materials from worn-out equipment, construction waste, and even organic matter from the settlement's waste streams. This circular economy approach will make Martian mining operations models of sustainability that could influence industrial practices throughout the solar system. Perhaps most importantly, the success of mining operations on Mars will prove that humans can build industrial civilizations on other worlds without repeating the environmental mistakes that have sometimes accompanied resource extraction on Earth. The careful, sustainable approach to Martian mining will demonstrate that it's possible to develop the mineral resources needed for technological civilization, while maintaining respect for the planetary environment that makes that civilization possible, creating a template for responsible resource development throughout humanity's expanding presence in the cosmos. Communication between Mars and Earth will require humanity to develop new forms of patience and thoughtfulness, as the vast distances between our two worlds create time delays that transform every conversation into an exercise in contemplative correspondence rather than real-time dialogue. When Mars and Earth are at their closest approach, radio signals take about 4 minutes to travel between the planets, but when the worlds are on opposite sides of the Sun, that delay can stretch to 24 minutes or more. This means that every message sent from Mars to Earth, whether it's a casual hello to family or an urgent technical consultation, becomes a carefully crafted letter that must anticipate responses and contain complete thoughts, rather than the quick back-and-forth exchanges that characterize terrestrial communication. The daily routine of communication with Earth will become one of the most emotionally significant rituals for Mars colonists, as they gather around communication terminals to receive the precious data packets that contain news from home, personal messages from loved ones, and updates about events happening on the blue planet that grows more distant with each passing day. These communication sessions will be scheduled carefully to take advantage of optimal transmission windows when atmospheric conditions on both planets allow for the clearest signal quality. The arrival of new messages will be celebrated like the delivery of mail in frontier towns, with colonists eagerly sharing news and updates that connect them to the larger human community they've temporarily left behind. Personal messages between Mars and Earth will evolve into a new art form, as families and friends learn to communicate across the vast cosmic distances through carefully composed video letters, audio recordings, and written correspondence that capture not just information, but the emotional warmth that helps maintain relationships across space and time. Parents on Earth will record bedtime stories for their children living on Mars, knowing that those stories won't be heard until the next day, but trusting that the love embedded in every word will bridge the temporal gap. Children born on Mars will grow up creating video messages for grandparents they've never met in person, learning to express themselves in ways that can be preserved and transmitted across millions of miles of empty space. The technology infrastructure supporting Earth-Mars communication will represent one of humanity's most sophisticated information networks, using powerful radio transmitters, orbital relay satellites, and advanced signal processing to maintain reliable contact despite the challenging conditions of interplanetary space. Solar interference, atmospheric disturbances, and the occasional alignment of planets that blocks direct communication paths will require backup systems and communication protocols that ensure important information can always get through, even if it takes longer than usual. The deep space communication networks will gradually expand to include relay stations throughout the solar system, creating an interplanetary internet that connects human settlements wherever they might be established. Emergency communication protocols will be designed to ensure that critical information can be transmitted quickly and clearly, even under challenging conditions, with standardized formats and compression techniques that maximize the information content of every transmission. Medical emergencies on Mars might require a real-time consultation with specialists on Earth, leading to the development of communication systems that can support remote diagnosis and treatment. Guidance despite the inevitable time delays. These systems will include high-resolution imaging, detailed telemetry from medical monitoring equipment, and sophisticated AI assistants that can provide immediate response while waiting for expert advice from Earth. The psychological impact of communication delays will require Mars colonists to develop new forms of emotional resilience and independence, as they learn to make decisions and solve problems without the immediate input and support that Earth-based humans take for granted. The inability to have real-time conversations with loved ones will initially feel isolating and challenging, but over time, many colonists may find that the slower, more thoughtful pace of interplanetary communication actually deepens their relationships and encourages more meaningful exchanges. The effort required to craft a good message across interplanetary distances will make every communication feel more intentional and valuable. News and entertainment from Earth will be transmitted in large data packages that colonists can access at their leisure, creating a kind of time-shifted connection to Earth culture and current events. Mars settlements will receive regular updates that include news, broadcasts, movies, television shows, music, books, and educational content that help maintain cultural connections to Earth, while also providing entertainment and intellectual stimulation during the long Martian nights. These cultural transmissions will become shared experiences that bring Mars communities together, as colonists gather to watch the latest Earth movies or discuss news events that happened days ago, but are just reaching their distant world. Evolution of Earth-Mars communication will eventually lead to the development of new forms of interplanetary culture and identity, as Mars colonists create their own news, entertainment, and cultural content to share with Earth. and other human settlements throughout the solar system. The time delays that initially seem like obstacles will become features of a new kind of human community that spans multiple worlds, where patience, thoughtfulness, and the careful craft of meaningful communication become essential skills for maintaining the social bonds that connect humanity across the vast reaches of space. The weather on Mars will teach human settlers to live with a climate that is both hauntingly familiar and utterly alien, where the basic patterns of atmospheric circulation, seasonal change, and daily temperature variation follow principles that Earth dwellers can understand, but with extremes and peculiarities that require entirely new approaches to clothing, shelter, and daily planning. The thin Martian atmosphere, composed mostly of carbon dioxide with traces of nitrogen and argon, creates weather patterns that are often more dramatic and far-reaching than anything experienced on Earth, where massive dust storms can engulf the entire planet for months at a time, while temperature swings of 100 degrees Fahrenheit between day and night are considered perfectly normal. The daily rhythm of Martian weather will become as familiar to colonists as checking Earth weather forecasts, but with unique considerations that reflect life on a world where atmospheric pressure is less than 1% of Earth's sea level pressure. Morning weather briefings will include not just temperature and wind conditions, but atmospheric opacity readings that indicate how much dust is suspended in the air, solar irradiance measurements that affect the efficiency of solar panels, and static electricity warnings that are particularly important on a world where dust storms can generate enormous electrical charges. Colonists will learn to read the subtle signs of approaching weather changes, the way the butterscotch sky shifts to deeper amber tones before a dust storm, or how the morning frost patterns on rocks indicate the likelihood of afternoon wind gusts. The dust storms of Mars represent one of the most spectacular and challenging aspects of Martian weather, ranging from brief local dust devils that danced across the landscape like miniature tornadoes, to planet-wide storms that can last for months and reduce solar energy collection to almost nothing. These dust events aren't just inconveniences. They're major weather systems that require careful preparation and can significantly impact colony operations. Local dust storms might require colonists to postpone outdoor work and secure loose equipment, while regional storms could force settlements into conservation mode, where non-essential systems are shut down to preserve power and life support capabilities. Until clear skies return, the seasonal patterns on Mars will create a weather calendar that spans nearly 2 Earth years. As the red planet takes 687 Earth days to complete its orbit around the Sun, Martian seasons are further complicated by the planet's elliptical orbit, which means that southern hemisphere summer occurs when Mars is closest to the Sun, creating more extreme seasonal variations in the south than in the north. Colonists will learn to plan major construction projects, agricultural cycles, and exploration missions around these extended seasonal patterns, taking advantage of the warmer months for outdoor work while using the colder periods for indoor projects and equipment maintenance. Temperature variations on Mars are extreme by Earth standards, with equatorial regions experiencing summer highs that might reach 70 degrees Fahrenheit during the day, only to plummet to -100 degrees Fahrenheit before dawn. These dramatic temperature swings are caused by the thin atmosphere's inability to retain heat, creating conditions that require habitats to be designed with exceptional insulation and heating systems. Colonists will develop daily routines that work with rather than against these temperature cycles, scheduling outdoor activities for the warmest parts of the day, while using the cold nighttime hours for indoor work and rest. The wind patterns on Mars create their own unique challenges and opportunities for human settlement. With global circulation patterns that can transport dust and moisture around the entire planet, but also provide potential energy sources for wind-powered generators, Martian winds can reach speeds of over 60 miles per hour during major storms, but the thin atmosphere means these winds carry much less force than similar speeds would on Earth. However, the electrostatic properties of Martian dust make wind storms particularly problematic for sensitive electronic equipment, requiring special protective measures for solar panels, communication equipment, and other technology that must operate in the open Martian environment. Weather prediction on Mars will become a crucial technology for colony survival and efficiency, using orbital satellites, surface weather stations, and atmospheric modeling to provide colonists with the advance warning they need to prepare for challenging conditions. The predictable orbital mechanics of Mars make some aspects of weather forecasting easier than on Earth, as seasonal patterns and daily temperature cycles follow reliable mathematical relationships. However, the chaotic nature of dust storm formation and the complex interactions between surface conditions and atmospheric circulation create forecasting challenges that will require new meteorological models specifically adapted to Martian conditions. The gradual adaptation to Martian weather will teach colonists new forms of patience and flexibility as they learn to work with natural cycles that operate on different timescales and with different intensities than Earth weather. The beauty of Martian weather phenomena, from the ethereal blue sunsets caused by dust scattering to the delicate frost patterns that form on rocks during cold nights, will provide daily reminders that they are living on a world with its own unique character and rhythm, where learning to read and respect the atmospheric patterns becomes an essential skill for thriving in humanity's first permanent settlement beyond Earth. The exploration of Mars will unfold like the world's greatest treasure hunt, where every ridge, canyon, and ancient crater holds clues to the planet's 4-billion-year history and secrets that could reshape our understanding of life, geology, and the possibilities for human habitation throughout the solar system. The Martian landscape offers an incredible diversity of terrain that ranges from vast plains of rust-colored sand to towering volcanic peaks that dwarf Earth's highest mountains, from deep canyons that make the Grand Canyon look modest to polar ice caps that advance and retreat with the alien seasons of humanity's second home. The daily work of exploration will blend the careful methodology of scientific research with the irresistible human urge to venture beyond the next hill and see what wonders await discovery. Exploration teams will set out from the main settlement in pressurized rovers that serve as mobile homes and laboratories, equipped with everything needed for multi-day expeditions across the Martian terrain. These expeditions will follow carefully planned routes that balance scientific objectives with safety considerations, always maintaining communication with the base settlement while gradually expanding the mapped and understood territory around humanity's foothold on the Red Planet. The geological wonders of Mars will provide endless opportunities for discovery and wonder, as explorers encounter landscapes that tell the story of a planet's evolution through dramatically different climate periods. The massive shield volcanoes of the Tharsis region, including Olympus Mons, a mountain so large it would cover the entire state of Arizona and rise 3 times higher than Mount Everest, represent volcanic activity on a scale that Earth has never experienced. These gentle giants, now dormant, created much of the dramatic topography that makes Mars such a visually spectacular world, and their exploration will reveal secrets about planetary formation and the deep geological processes that shape rocky worlds throughout the universe. The canyon systems of Mars, particularly the vast Valles Marineris that stretches across nearly a quarter of the planet's circumference, will offer explorers the chance to descend into Mars's geological history, like reading the pages of a stone book written over billions of years. These canyons expose rock layers that preserve evidence of Mars's ancient past, including periods when the planet may have had a thicker atmosphere, flowing rivers, and possibly even oceans. Exploration teams will carefully document and sample these exposed rock faces, searching for signs of past water activity and perhaps even fossilized evidence of ancient Martian life. The search for water will guide much of the exploration effort, as teams follow the traces of ancient riverbeds, dried lake beds, and underground aquifers that could provide the resources needed for expanding human settlement. The discovery of accessible water sources will determine where future settlements can be established and how quickly the human presence on Mars can grow from a small research outpost to a thriving colony. Every expedition will carry sensitive instruments, capable of detecting water in various forms, from surface frost to subsurface ice to mineral deposits that indicate past water activity. The exploration of Mars will also focus on finding the best locations for future settlement expansion, identifying sites that offer combinations of water access, solar exposure, protection from dust storms, and geological stability that make them suitable for human habitation. Each potential settlement site will be carefully surveyed and mapped, with teams establishing supply caches and communication relay stations that gradually extend the reach of human presence across the Martian landscape. These exploration efforts will create a growing network of known routes, supply points, and emergency shelters that make the Martian wilderness increasingly accessible and safe for human travel. The biological exploration of Mars represents perhaps the most exciting aspect of landscape investigation. as teams search for signs of past or present life in environments that might have supported biological activity. Certain areas of Mars, particularly those with evidence of past water activity or current subsurface water sources, will be explored with extreme care to avoid contaminating potential biological samples with Earth organisms. The discovery of even microbial life on Mars would revolutionize our understanding of biology and the prevalence of life throughout the universe, making every exploration expedition a potential voyage of discovery that could change everything we know about our place in the cosmos. The cultural and psychological impact of exploring Mars will be just as significant as the scientific discoveries, as human explorers develop personal relationships with specific locations, geological features, and scenic vistas that become meaningful parts of their daily lives. Exploration teams will begin the process of naming Martian landmarks, creating the first human geography for an alien world and establishing the cultural foundations that will help future generations of Mars settlers feel connected to their planetary home. Perhaps most importantly, the exploration of Mars will demonstrate humanity's endless capacity for curiosity and discovery, proving that our species can adapt the spirit of exploration that has driven human expansion across Earth to the challenge of understanding and inhabiting other worlds. Every expedition will add to the growing body of knowledge that transforms Mars from an alien world to a familiar landscape, gradually making the red planet feel less like a destination and more like home. The quiet hum of energy systems on Mars will represent the gentle heartbeat of human civilization on the red planet, where generating reliable power becomes not just a technological challenge but the fundamental requirement that makes everything else possible, from breathing processed air to growing food in pressurized greenhouses, to maintaining the communication links that connect Mars colonists to their Earthbound families. The energy infrastructure of Mars will need to be more robust, efficient, and redundant than anything built on Earth, because power failure on a world without breathable atmosphere or survivable temperatures isn't just an inconvenience, it's a matter of life and death for every human on the planet. Solar power will form the backbone of Martian energy systems, taking advantage of the planet's clear, dust-free skies during good weather to capture the sunlight that travels 142 million miles from the sun to reach the red planet's surface. While Mars receives only about 43% of the solar energy that reaches Earth, the lack of atmospheric water vapor and the reduced atmospheric density mean that Martian solar panels can operate with remarkable efficiency when conditions are favorable. The challenge lies in dealing with the periodic dust storms that can reduce solar energy collection to almost nothing for weeks or months at a time, requiring energy storage systems and backup power sources that can maintain colony operations. Even when the sun is completely obscured by atmospheric dust, nuclear power will provide the reliable baseline energy that Mars settlements need to survive the periodic solar energy droughts caused by dust storms and the reduced solar during Martian winter. Small modular reactors, designed specifically for space applications, will operate continuously regardless of weather conditions, providing the essential power needed for life support systems, heating, and critical operations that cannot be interrupted even briefly. These nuclear systems will be designed with multiple safety systems and automated controls that can operate reliably for years without major maintenance, creating the energy security that allows Mars colonists to sleep peacefully knowing that their life support systems will continue operating through any environmental challenges the red planet might present. Energy storage will become one of the most crucial technologies on Mars, where the ability to store power during favorable conditions and release it during challenging periods determines the difference between a thriving settlement and a struggling outpost. Advanced battery systems, probably using lithium or other lightweight materials that can be manufactured locally, will store solar energy collected during clear weather for use during dust storms or nighttime operations. These storage systems will be distributed throughout the settlement to provide redundancy and ensure that critical systems can continue operating even if individual storage units fail or require maintenance. The energy efficiency of every system on Mars will be optimized to an extent that would seem obsessive on Earth, where power consumption directly affects the survival capacity of the entire settlement. LED lighting will provide illumination with minimal energy use, while advanced insulation systems will reduce the energy needed for heating and cooling. All electronic equipment will be selected for maximum efficiency and minimal power consumption, and colonists will develop daily routines that work with rather than against the natural energy cycles of their settlement. The energy consciousness that develops on Mars will likely influence more sustainable practices back on Earth, as colonists learn to live comfortably while using far less energy than typical Earth lifestyles require. Wind power on Mars will provide supplemental energy during favorable conditions. Despite the challenges of generating useful power in an atmosphere that is less than 1% as dense as Earth's, Martian wind turbines will need to be designed specifically for the low-density atmosphere, with larger blades and different gearing systems that can capture energy from the high-velocity winds that occasionally sweep across the planet's surface. While wind power alone cannot provide reliable baseline energy for Mars settlements, it can supplement solar and nuclear power during favorable weather conditions and help reduce the overall energy demands on the primary power systems. Geothermal energy represents a potential long-term energy source that could support much larger Mars settlements, as the planet's geological activity creates subsurface heat sources that could be tapped for both power generation and direct heating applications. The exploration and development of geothermal resources will require significant initial investment in drilling and extraction equipment, but successful geothermal installations could provide constant, reliable energy that operates independently of weather conditions and requires minimal ongoing fuel supplies. Energy distribution systems on Mars will be designed with redundancy and fault tolerance that exceeds anything built on Earth, ensuring that power outages in one part of a settlement don't cascade into system-wide failures that could threaten the entire colony. Underground power cables will protect distribution systems from the harsh surface environment, while automated switching systems will reroute power around damaged components to maintain service to critical systems. The energy grid will be designed so that individual buildings or sections can operate independently if necessary, creating a resilient power infrastructure that can maintain operations even under challenging conditions. The mastery of energy systems on Mars will eventually make the Red Planet a launching point for human expansion throughout the solar system, as the technologies and expertise developed for Martian power generation prove applicable to even more challenging environments on moons and asteroids, where human settlements may eventually be established. The emergence of art and culture on Mars will represent one of the most beautiful and essentially human aspects of life on the Red Planet, proving that even in the most challenging and alien environments, the human spirit continues to create beauty, meaning, and expression that nourishes the soul as surely as food nourishes the body. The first Martian artists will work with materials and inspirations that no human has ever encountered before, using the unique properties of reduced gravity, alien landscapes, and the profound psychological experience of living on another world to create entirely new forms of artistic expression that could never have emerged on Earth. The visual arts on Mars will be transformed by the planet's unique aesthetic environment, where rust-colored landscapes, butterscotch skies, and the ethereal beauty of two small moons racing across alien heavens provide inspiration that no Earth-based artist has ever had access to. Painters will learn to capture the subtle color variations of Martian light, which changes throughout the day in ways that are both similar to and distinctly different from Earth's familiar lighting patterns. Sculptors will take advantage of the reduced gravity to create works that would be impossible on Earth, with delicate, towering structures that seem to defy physics, while celebrating the lighter touch of Martian gravity on human creativity. The performing arts will undergo a particularly dramatic transformation on Mars, as dancers and athletes discover new possibilities of movement in an environment where jumping higher, moving more gracefully, and sustaining longer periods of airborne motion become natural parts of artistic expression. Martian dance will likely evolve into something entirely new, combining the traditional movements developed in Earth's gravity with floating gestures that take advantage of the Red Planet's gentler gravitational pull. Sports and recreational activities will also evolve uniquely Martian characteristics, with games that would be impossible on Earth becoming part of the cultural traditions that help define what it means to be human on Mars. Music on Mars will face the interesting challenge of acoustic environments that are dramatically different from Earth's atmospheric conditions. where the thin air and different atmospheric composition create unique sound propagation characteristics that musicians will need to learn and adapt to. Indoor concert spaces will become crucial cultural gathering points, where colonists can enjoy musical performances in Earth-normal atmospheric conditions, while outdoor music will require electronic amplification and different instrumental techniques adapted to the Martian environment. The psychological importance of music for maintaining morale and cultural connection will make musical instruments and audio equipment essential items for any Mars settlement. As important for human well-being as any life support technology, literature and storytelling on Mars will capture experiences and emotions that no previous generation of humans has ever encountered, creating an entirely new genre of human expression based on the actual lived experience of being a multiplanetary species. The first Martian poets will write about watching Earth rise over alien horizons, about the silence of a world without weather, about the strange beauty of landscapes that have never known life. These literary works will serve not just as artistic expression but as historical documents that preserve the emotional and psychological experience of humanity's expansion into the cosmos for future generations who may take interplanetary life for granted. The crafts and decorative arts on Mars will make use of local materials in ways that create distinctly Martian aesthetic traditions, with artists learning to work with the unique properties of Martian minerals, metals, and other resources to create functional and beautiful objects for daily use. The necessity of making everything locally will encourage a renaissance of traditional crafting skills, as colonists learn to create their own textiles, pottery, metalwork, and decorative objects using techniques that blend ancient human knowledge with the unique opportunities provided by Martian materials and reduced gravity. Cultural celebrations and festivals on Mars will evolve to mark both Earth traditions and uniquely Martian milestones, creating new holidays and observances that reflect the specific experiences of life on the Red Planet. The anniversary of the first landing, the celebration of successful harvests from Martian greenhouses, and observances that mark the orbital positions of Earth and Mars will become part of the cultural calendar that helps create a sense of community and shared identity among Mars colonists. These celebrations will blend familiar Earth customs with new traditions that emerge from the unique challenges and achievements of life on another world. The psychological and social importance of art and culture on Mars cannot be overstated, as creative expression provides essential emotional outlets and community bonding experiences that help maintain mental health and social cohesion in an isolated, artificial environment. Art therapy, music therapy, and creative workshops will become important components of Mars settlement life, helping colonists process the complex emotions of living so far from Earth, while building the cultural foundations that will help Mars communities thrive across generations. Perhaps most remarkably, the art and culture that emerges on Mars will eventually influence and enrich human culture throughout the solar system, as the unique perspectives and creative innovations developed on the Red Planet flow back to Earth and out to other human settlements, creating the first truly interplanetary cultural exchange in human history. Bafna Mars will become humanity's greatest natural laboratory, where proximity to an alien world will enable scientific discoveries that would be impossible from Earth-based observations alone, transforming our understanding of planetary science, astrobiology, geology, and atmospheric dynamics through hands-on research conducted by scientists who can walk among the phenomena they're studying. Living and working on Mars will provide researchers with unprecedented access to a planetary environment that has been preserved like a frozen museum for billions of years, where the thin atmosphere and lack of plate tectonics have left geological features and chemical signatures intact that could reveal secrets about the early history of rocky planets throughout the universe. The search for life on Mars will be revolutionized by the presence of human researchers who can make real-time decisions about where to look and how to investigate promising sites. Rather than relying on the pre-programmed instructions and limited capabilities of robotic rovers, human scientists will be able to follow hunches, investigate unexpected discoveries immediately, and use sophisticated laboratory equipment to analyze samples in ways that provide much more detailed information than can be transmitted back to Earth. The possibility of finding evidence of past or present Martian life will guide much of the early scientific work on the planet, with researchers carefully investigating subsurface water sources, mineral deposits that might preserve biological signatures, and chemical environments that could support microbial life. Geological research on Mars will provide invaluable insights into planetary formation and evolution. As scientists study a world that has preserved evidence of geological processes spanning billions of years without the constant recycling and erosion that obscures Earth's early history, the massive volcanic formations, impact craters, and sedimentary layers exposed in Martian canyons will serve as textbooks written in stone, revealing how rocky planets develop, change, and respond to different atmospheric and climate conditions over geological time. This research will not only enhance our understanding of Mars itself, but will provide crucial data for understanding how Earth formed and evolved, and what we might expect to find on rocky planets orbiting other stars. Atmospheric science on Mars will benefit enormously from continuous, detailed monitoring by human researchers who can deploy sophisticated instruments and respond quickly to changing conditions like dust storms, seasonal variations, and unusual weather phenomena. The Martian atmosphere provides a natural laboratory for studying atmospheric dynamics under conditions that are significantly different from Earth's, offering insights into how atmospheres behave on planets with different mass, composition, and distance from their star. This research will be crucial for understanding climate change on Earth and for predicting atmospheric conditions on potentially habitable exoplanets that human telescopes are discovering around other stars. The unique conditions on Mars will enable entirely new types of scientific experiments that take advantage of the planet's reduced gravity, thin atmosphere, and different radiation environment to study physical and biological phenomena under conditions that cannot be replicated on Earth. Materials. Science experiments will explore how different substances behave in Martian gravity and atmospheric conditions, potentially leading to the development of new alloys, composites, and manufacturing techniques that could benefit both Mars settlements and Earth-based industries. Biological research will investigate how Earth organisms adapt to Martian conditions, providing insights into the limits and adaptability of life that could inform the search for life elsewhere in the universe. The astronomical research opportunities on Mars will be extraordinary, as the planet's thin atmosphere and lack of light pollution provide observing conditions that are superior to Earth in many ways, while the planet's location in the solar system offers unique perspectives on other planets, asteroids, and cosmic phenomena. Mars-based telescopes will be able to observe the universe with clarity that rivals space-based instruments, while being much easier to maintain and upgrade. The red planet's position relative to Earth will also enable baseline measurements for astronomical observations that could improve our understanding of stellar distances, planetary motions, and the structure of the solar system. Climate research on Mars will provide crucial data about how planetary climates evolve and respond to changes in atmospheric composition, solar radiation, and other variables that affect global temperature and weather patterns. The evidence preserved in Martian geology suggests that the planet once had a much thicker atmosphere and possibly liquid water on its surface, making Mars a natural laboratory for studying climate change on a planetary scale. Understanding how and why Mars lost its thick atmosphere could provide important insights into the stability of planetary climates and the factors that determine whether a planet remains habitable over geological time. The collaborative nature of scientific research on Mars will bring together researchers from multiple disciplines who can work together in ways that are difficult to achieve when scientists are scattered across different Earth-based institutions. The small, close-knit communities of Mars settlements will foster interdisciplinary collaboration and rapid sharing of discoveries, potentially accelerating the pace of scientific advancement while creating new approaches to research that combine multiple fields of study. The scientific discoveries made on Mars will ultimately benefit all of humanity, advancing our understanding of the universe while providing practical knowledge that supports the expansion of human civilization throughout the solar system. Gentle flow of goods and resources between Mars and Earth will eventually create humanity's first interplanetary economy, where the unique advantages of each world combine to create prosperity and innovation that neither planet could achieve alone. This cosmic commerce won't happen overnight. It will develop gradually as Mars settlements grow from struggling survival outposts to thriving communities. capable of producing goods and services that are valuable enough to justify the enormous cost and complexity of shipping them across millions of miles of space. The foundation of interplanetary trade will be built on the principle that some things are much easier or more efficient to produce on Mars than on Earth, while other resources and products flow in the opposite direction, creating a gentle but profitable exchange that benefits both worlds. Mars will likely become humanity's first major exporter of rare minerals and metals that are difficult or expensive to extract on Earth, where environmental regulations, labor costs, and geological accessibility make mining operations increasingly challenging and costly. The red planet's geological history has concentrated valuable minerals in ways that make them more accessible than similar deposits on Earth, while the lower gravity makes it easier to extract and process large quantities of ore, platinum group metals, rare earth elements essential for electronics and renewable energy systems, and other valuable materials could flow from Martian mines to Earth markets, providing the economic foundation that makes large-scale Mars colonization financially sustainable. The unique manufacturing opportunities provided by Mars's reduced gravity and thin atmosphere will create niche products that cannot be produced anywhere else in the solar system, from ultra-lightweight materials that take advantage of low gravity manufacturing processes to specialized electronics that benefit from the planet's radiation environment and atmospheric conditions. Martian factories might become the preferred location for producing certain types of advanced materials, precision instruments, or biotechnology products that require specific environmental conditions that are naturally available on the red planet. These high-value, low-mass products will be ideal for interplanetary shipping, where every kilogram of cargo represents a significant transportation cost. Scientific research and intellectual property will represent some of the most valuable exports from Mars to Earth, as the unique research opportunities available on the red planet generate discoveries, technologies, and innovations that have applications throughout the solar system. Medical research conducted in Martian gravity, atmospheric studies that reveal new climate science, and astronomical observations made from Mars's superior observing conditions will create intellectual property and technological innovations that can be licensed and applied on Earth. The data research results and technological developments flowing from Mars research institutions will create a knowledge-based economy that leverages the red planet's unique advantages for scientific discovery. Earth will continue to be the primary source of manufactured goods, complex technology, and cultural products that Mars settlements need but cannot yet produce locally, creating a trade flow that brings advanced electronics, specialized equipment, and luxury items to the growing Martian population. Books, movies, music, art, and other cultural products will flow from Earth to Mars, helping maintain cultural connections while generating revenue for Earth-based creators. As transportation costs decrease and Mars populations grow, this cultural trade will expand to include a wider range of consumer goods that make life on Mars more comfortable and varied. The development of interplanetary shipping infrastructure will make trade between worlds increasingly efficient and cost-effective, with specialized cargo vessels designed for the long journey between Earth and Mars, optimized for different types of cargo and shipping schedules. Some ships will be designed for high-value, time-sensitive cargo that needs to reach its destination quickly, while others will focus on bulk shipping of raw materials and low-priority goods that can travel slower but more economically. The establishment of regular shipping schedules that take advantage of optimal orbital alignments will make interplanetary trade as reliable and predictable as international shipping on Earth. The financial systems supporting interplanetary trade will require new approaches to banking, currency exchange, and commercial law that account for the communication delays and physical distances involved in transactions between worlds. Digital currencies and automated trading systems will likely play important roles in facilitating commerce across space, while new forms of commercial insurance will cover the unique risks of interplanetary shipping. The development of Mars-based financial institutions will eventually give the red planet economic independence and the ability to engage in trade with other human settlements throughout the solar system. The economic relationship between Earth and Mars will gradually shift from Mars as a dependent colony requiring constant support to a true trading partnership where both worlds benefit from their unique advantages and capabilities. This transition will mark Mars's evolution from an outpost of Earth civilization to an independent member of humanity's interplanetary community, capable of standing on its own while contributing to the prosperity and knowledge of the entire human species. The success of Earth-Mars trade will establish the economic principles and infrastructure that will support commerce throughout the solar system as human settlements expand to the asteroids, outer planets, and eventually to other star systems, creating a foundation for truly cosmic civilization. The transformation of Mars from a small survival outpost to a thriving, self-sustaining civilization will happen gradually, almost imperceptibly, as daily improvements in infrastructure, population growth, and technological capability combine to create something that future historians will recognize as the moment humanity truly became a multiplanetary species. This growth won't happen through dramatic expansions or sudden changes, but through the patient accumulation of small successes, each new building constructed, each additional family that chooses to make Mars their permanent home, each technological breakthrough that makes life on the red planet a little easier and more comfortable. The colony will expand organically, like a garden growing from carefully tended seeds, into a flourishing ecosystem that supports increasingly complex forms of human community and culture. The physical expansion of Mars settlements will follow practical needs and opportunities, with new residential areas, workshops, laboratories, and recreational facilities being added as the population grows and the community's capabilities expand. The original landing site will gradually become the historic downtown area of what might eventually be called humanity's first Martian city, surrounded by newer districts that reflect different phases of colonial development and the evolving needs of a maturing society. Transportation corridors will connect different parts of the growing settlement through pressurized walkways and vehicle tunnels that protect residents from the Martian environment, while allowing easy movement between residential areas, work sites, and community facilities. The governance of the growing Mars colony will need to evolve from the hierarchical, mission-oriented structure appropriate for a small, research outpost to more democratic and representative forms of decision that reflect the diverse needs and interests of a permanent civilian population. As the settlement grows beyond a few dozen specialists to include hundreds or thousands of people from different backgrounds and with different goals, the community will need to develop new institutions and processes for making collective decisions about resource allocation, expansion priorities, and the countless small choices that shape daily life in any human community. This evolution toward self-governance will represent one of the most important milestones in Mars's transition from dependency on Earth to true independence. Immigration from Earth will gradually shift from carefully selected specialists sent on specific missions to individuals and families who choose Mars as their preferred home, bringing with them the diverse skills, perspectives, and cultural backgrounds that create vibrant, sustainable communities. These new Martian residents will include not just scientists and engineers, but artists, teachers, entrepreneurs, craftspeople, and all the other types of people who create the rich social fabric that makes any place feel like home. The selection criteria for Mars immigrants will evolve from purely technical qualifications to include the personal qualities and motivations that indicate someone will thrive in and contribute to the growing Martian community. Economic independence will mark one of the most crucial phases in the colony's development. As Mars settlements transition from being economically dependent on Earth to generating enough value through local production, research, and trade to support their own growth and development, this economic maturity will happen gradually. As local manufacturing capabilities expand, agricultural production increases, and the unique advantages of Mars-based research and industry create valuable exports that can be traded for Earth goods and services. The achievement of economic sustainability will give Mars communities the resources and confidence needed to make long-term plans and investments in their future growth. Educational systems on Mars will evolve to serve both children born on the red planet and adults who need to acquire new skills. As the colony's needs change and expand, schools will blend traditional Earth-based curriculum with practical skills specific to Mars living, while adult education programs will help colonists adapt to new roles as the community grows. beyond its original narrow focus on survival and basic research. The development of Mars-based universities and research institutions will mark another important milestone, as the Red Planet begins producing its own expertise and knowledge rather than depending entirely on Earth-trained specialists. Cultural and social institutions will develop naturally as the Mars community grows, large enough to support the kind of specialized organizations and activities that make human communities rich and interesting places to live. Religious congregations, hobby clubs, sports leagues, artistic societies, and volunteer organizations will emerge to serve the social and spiritual needs of Mars residents, creating the same kinds of community connections that help people feel at home anywhere. These institutions will blend Earth traditions with uniquely Martian innovations, gradually creating a distinct Mars culture that honors its Earth heritage while developing its own character and traditions. The psychological transformation from survival mindset to growth mindset will represent perhaps the most important change in the evolution of Mars settlements, as colonists shift from focusing primarily on staying alive and maintaining basic systems to thinking about building something permanent and valuable for future generations. This mental transition will unlock creativity, entrepreneurship, and long-term planning that transforms Mars from a place where humans struggle to survive into a place where humans can thrive and build the foundations of an interplanetary civilization that could eventually support millions of people across multiple worlds throughout the solar system. The profound experience of seeing Earth as a small blue star in the Martian night sky will fundamentally change how Mars colonists understand their relationship to their home planet, creating a perspective that is both humbling and liberating as they witness firsthand the delicate beauty and cosmic insignificance of the world that gave birth to human civilization. From the surface of Mars, Earth appears as just another point of light among thousands of stars, visible to the naked eye but requiring no more attention than any other celestial object, unless you know specifically to look for it. This dramatic shift in perspective from Earth as the entire universe to Earth as one small world among many will create a psychological transformation that affects every aspect of how Mars settlers think about home, identity, and humanity's placed in the cosmos. The emotional impact of watching Earth rise over Martian horizons will never lose its power to move Mars colonists, even as the sight becomes familiar through daily repetition. Unlike the moon phases that gradually change Earth's appearance from our home planet, Earth maintains a relatively constant brightness and color when viewed from Mars. But its position in the sky shifts with the Martian day and the complex orbital dance between the two planets. During certain times of the Martian year, Earth appears as a morning star, rising before the sun and providing a bright blue beacon that signals the start of each new day. At other times, Earth becomes an evening star, hanging in the western sky after sunset and offering a gentle reminder of home before Mars colonists settle in for the night. The physical distance between Mars and Earth, ranging from 35 million miles at closest approach to over 200 million miles when the planets are on opposite sides of the sun, will be felt most acutely in the visual reminder of how small and vulnerable Earth appears from interplanetary distances. Mars colonists will develop an almost protective fondness for the little blue dot that represents not just their own origins, but the entire history of human civilization, all of human art and literature, and the homes of everyone they've ever known who remained behind. This perspective will likely make Mars settlers some of Earth's most passionate advocates for environmental protection and global cooperation, as they witness daily how precious and fragile their original home appears from the cosmic distances. The communication delays between Mars and Earth will reinforce the visual reminder of distance, as colonists experience firsthand how the vast emptiness of space affects even the speed of light transmission of radio signals. When Mars colonists look at Earth in their night sky, they know that any message they send will take between 4 and 24 minutes to reach the little blue star they're observing, depending on the current orbital positions of the two planets. This temporal separation will create a unique form of homesickness, not just the spatial longing for a distant place, but the temporal ache of being separated from Earth, not just by distance, but by time itself. The seasonal changes visible on Earth from Mars will provide Mars colonists with a gentle connection to the natural rhythms of their birth planet. As telescopic observations reveal the advancing and retreating ice caps, seasonal weather patterns, and the subtle color changes that indicate the progression of seasons on the blue world, these observations will become a form of meditation for homesick colonists. who can participate vicariously in Earth's seasonal cycles while adapting to the very different seasonal patterns of their new Martian home. The ability to observe Earth's weather systems, city lights, and even major geographical features through advanced telescopes will help maintain an emotional connection that makes the distance feel slightly less overwhelming. The philosophical implications of seeing Earth from another world will profoundly influence Mars' colonial culture, creating a generation of humans who understand viscerally that Earth is just one planet among many, that the political boundaries and conflicts that seem so important on Earth's surface are invisible from interplanetary distances, and that humanity's survival ultimately depends on our ability to expand beyond our birth world. This cosmic perspective will likely influence Mars' colonial politics, encouraging forms of governance and social organization that prioritize long-term survival and cooperation over short-term competition and resource conflicts. Letters and video messages sent from Mars to Earth will often include references to how Earth looks from the red planet, creating a new form of literature and communication that captures the emotional experience of seeing one's homeworld from cosmic distances. These communications will help Earthbound humans understand their planet's place in the larger universe while providing Mars colonists with a way to share the profound emotional impact of their unique perspective. Perhaps most importantly, the daily experience of seeing Earth as a distant star will remind Mars colonists that they are pioneers not just in geographical exploration, but in expanding human consciousness to truly cosmic scales. They will carry with them always the memory of how precious and beautiful Earth appears from interplanetary distances, creating a perspective that honors their origins while embracing their role as the first humans to call another world home. Mars will serve as humanity's gentle stepping stone to the stars, transforming from our species' greatest achievement into the foundation for even more ambitious journeys that will carry human consciousness and civilization throughout the solar system, and eventually to distant worlds orbiting other suns. The red planet will become our cosmic training ground, where we learn the essential skills of interplanetary living that will make possible the establishment of human settlements in the asteroid belt, on the moons of Jupiter and Saturn, and in the challenging environments of the outer solar system that would be impossible to reach directly from Earth's deep gravity well. The establishment of permanent human settlements on Mars will prove that our species can adapt to alien environments, create closed-loop life support systems, and maintain psychological health during the isolation and challenges of life far from Earth. These lessons learned through patient trial and error on Mars will become the foundation for human expansion to even more challenging destinations, where the techniques of atmospheric processing, local resource utilization, and sustainable community building developed on the red planet will be refined and adapted to environments that are even more hostile to human life. Mars colonists will become the teachers and pioneers who guide humanity's next great adventures, sharing their hard-won knowledge about what it takes to thrive on worlds that were never meant to support human life. The lower gravity and thinner atmosphere of Mars will make it an ideal launch point for missions to the outer solar system, where spacecraft can escape Martian gravity using far less energy than would be required to launch the same missions from Earth's surface. The red planet will gradually develop into humanity's primary spaceport for deep space exploration, with shipyards and fuel depots that support increasingly ambitious missions to Jupiter's moons, Saturn's rings, and the mysterious worlds of the outer planets. The water, ice, and carbon dioxide available on Mars will provide the raw materials for rocket fuel, while the planet's growing industrial base will manufacture the spacecraft, habitats, and life support systems needed for human expansion throughout the solar system. The moons of Jupiter will likely represent humanity's next major colonization target after Mars, offering environments that are both incredibly challenging and potentially rewarding for human settlement. Europa's subsurface ocean may harbor life forms that have evolved independently from Earth biology, while Ganymede and Callisto offer solid surfaces and abundant water ice that could support substantial human populations. The techniques for living in artificial environments developed on Mars will be essential for these Jovian settlements, which will need to operate in much higher radiation environments and with even greater isolation from Earth than Mars. Colonists' experience Saturn's moon system will provide another frontier for human expansion, with Titan offering a thick atmosphere and liquid methane lakes that create unique opportunities for both scientific research and resource extraction. The technologies developed for processing Martian atmosphere and extracting useful materials from alien environments will be crucial for establishing human settlements in the Saturn system, where the abundant organic compounds and energy sources could support large populations of space colonists engaged in research, manufacturing, and the continued expansion of human presence throughout the outer solar system. The asteroid belt will become humanity's primary source of metals, rare minerals, and other resources needed to support growing populations throughout the solar system, with Mars serving as the coordination center and supply base for mining operations among the countless small worlds that orbit between Mars and Jupiter. The reduced gravity and established infrastructure of Mars will make it the natural headquarters for asteroid mining companies and the processing facilities that turn raw asteroid materials into the manufactured goods needed by human settlements throughout the solar system. The long-term vision of interstellar travel will begin on Mars, where the technologies and social systems needed for multi-generational voyages to other star systems will be developed and tested through the patient work of creating sustainable human communities that can operate independently for centuries. The experience of building self-sufficient civilizations on Mars will provide the proof of concept for generation ships that could carry human settlers to potentially habitable planets orbiting nearby stars, where the lessons learned on the Red Planet will guide the establishment of humanity's first interstellar colonies. The cultural and philosophical impact of Mars colonization will inspire even greater adventures, as humans who have grown up on multiple worlds develop a cosmic perspective that sees interplanetary travel as normal and interstellar expansion as the natural next step in human development. The children born on Mars will grow up with expectations and capabilities that make them natural pioneers for even more challenging frontiers, carrying forward the spirit of exploration and adaptation that makes human expansion throughout the universe not just possible but inevitable. Perhaps most importantly, Mars will prove that human civilization is not bound to any single world, that our species has the creativity, determination, and adaptability needed to establish thriving communities anywhere in the universe where we can create the basic conditions needed for human life. The Red Planet will become the first chapter in humanity's cosmic story, demonstrating that we are truly a spacefaring species capable of carrying life, consciousness, and culture to worlds that have waited billions of years for the gentle touch of intelligence to awaken their potential. As our gentle journey to Mars draws to its peaceful close, we find ourselves forever changed by the vision of humanity's greatest adventure, unfolding across the rust-colored plains and butterscotch skies of our future second home. We've walked together through the patient process of transforming an alien world into a place where human children will someday play under twin moons, where families will gather around dinner tables to share meals grown in Martian soil, and where the dreams that have guided our species since we first looked up at the stars will finally become the daily reality of a truly interplanetary civilization. The Red Planet has revealed itself to us not as a cold, hostile destination, but as a world waiting patiently for the gentle touch of human wisdom, creativity, and love to awaken its potential as humanity's cosmic garden. Tonight, as you drift toward sleep, you can carry with you the quiet confidence that this incredible journey from dream to reality is already underway, happening right now through the patient work of engineers, scientists, and dreamers who understand that the most important human achievements always begin with someone believing that the impossible can become inevitable through persistent, careful effort. Somewhere at this very moment, rockets are being designed that will carry the first Mars settlers on their 9-month voyage between worlds, while technologies are being perfected that will transform the Red Planet's thin atmosphere into breathable air and its frozen water into the foundation of thriving communities. The future we've explored together isn't a distant fantasy, but a near-term reality that current children may live to see and participate in. The Mars of our imagination has shown us something profound about human nature, that we are not bound by the circumstances of our birth, not limited by the world that shaped our evolution, but capable of adapting our ancient capacity for exploration and community, building to environments that our ancestors could never have imagined. The same qualities that carried humans across Earth's oceans, over its mountain ranges, and into its most challenging environments will guide us gently across the cosmic ocean to establish homes among the stars. the courage required for Mars colonization isn't the dramatic heroism of adventure stories, but the quiet determination to solve problems, support each other, and build something beautiful and lasting in places where beauty and permanence have never existed before. As sleep approaches, let your mind wander across the Martian landscape we've come to know so well, the vast plains where rovers have left their wheel tracks like the first tentative steps of human exploration, the towering volcanoes that dwarf Earth's mountains and remind us of the incredible geological forces that shape planetary worlds, the polar ice caps that hold the water reserves that will sustain future Mars cities. Picture the first human settlements taking root in this landscape, growing from small survival shelters into bustling communities, where the sounds of children playing and the gentle hum of atmospheric processors create the soundtrack of humanity's expansion into the cosmos. The people we've imagined living on Mars, the farmers tending greenhouse crops under alien skies, the scientists making discoveries that reshape our understanding of life and planetary evolution, the families raising children who will grow up as citizens of two worlds, represent the best possibilities of human nature, expressed in the most challenging circumstances our species has ever voluntarily embraced. These future Mars colonists will carry forward not just the technologies and techniques needed for survival on an alien world, but the values and wisdom that make human communities worth preserving and expanding throughout the universe. Your dreams tonight might be filled with the rust-colored horizons of Mars, the gentle light of a distant sun casting long shadows across alien geology, or the blue dot of Earth hanging in the Martian night sky as a reminder of home and the incredible journey that carried humanity from one world to another. These aren't just beautiful images, but glimpses of a future that connects us all, whether we personally travel to Mars or remain on Earth, to the grand adventure of human consciousness expanding beyond its birth world, to embrace the infinite possibilities waiting among the stars. The greatest gift of our Mars journey together has been the recognition that human dreams, when nurtured with patience, wisdom, and persistent effort, have the power to literally transform worlds and create realities that surpass even our most ambitious imaginings. The red planet represents proof that nothing is impossible for a species creative enough to envision living on other worlds and determined enough to make those visions real through the gentle accumulation of knowledge, technology, and cooperative effort. Sweet dreams from the red planet, where humanity's next great adventure is already beginning in the laboratories, workshops, and imaginations of people who understand that the most important journeys start not with dramatic departures, but with quiet decisions to believe that impossible destinations can become home through the patient application of human ingenuity, courage, and love. Sleep well, knowing that you've been part of envisioning humanity's cosmic future, where the gentle spirit of exploration that brought us to Mars will carry us eventually to worlds we can't yet imagine, creating an endless frontier of discovery and wonder among the infinite stars.